Hi guys, Audrey here. So today we're going to talk about geometric series. Um, we know that a geometric series is of the form the sum n equals 1 to infinity of a times r to the n minus 1. Now in class we saw that the general term for the sequence of partial sums of a geometric series is given by s sub n is equal to a times 1 minus r to the power of n all divided by 1 minus r. And we use that general term to show that a geometric series converges when the value of r is between -1 and 1, not inclusive, and we use that general term to show what the geometric series converges to. So the question is, where does this general term come from? So that's what we're going to try to show today. We're going to start off by just expanding the geometric series to the nth term. So s sub n we'll say is n equals 1 all the way up to n of a r to the n minus 1. And now I'm going to expand this thing. So when I plug in 1, I get a, then plus ar, then plus ar squared, then plus ar cubed, plus dot dot dot, plus. So this came from plugging in 1, 2, 3, 4. So now I'm going to plug in minus 1. So if I'm plugging in minus 1, what that means I'll have here is ar to the n minus 2. So n minus 1 minus 1 gives me n minus 2. And then lastly, I'm going to plug in n, which will result in what I have there in the series to begin with, which is just ar to the n minus 1. Okay, so now I'm going to do something a little bit odd. I'm going to take this s sub n and I'm going to multiply it by r. So the reason I'm going to do that is right now I can't think of this as a general term because I have all this extra stuff right here in the middle. This like plus dot 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 would stop me from taking the limit of this thing. It would stop me from being able to evaluate it easily. That plus dot 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 is kind of like this unknown amount of stuff in the middle, and it stops me from being able to easily use this thing. So we want to get it to the form that we have up there, the s in a 1 minus r to the n over 1 minus r. So I'm going to do something weird. Like I said, I'm going to multiply this by r. So I'm taking s sub n and I'm multiplying it by r. So then I will have r s sub n. And if I multiply each of those terms by r, I'm distributing the r to each of the terms inside. I'll get ar plus ar squared plus ar cubed plus ar to the fourth plus dot 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 plus at the n minus 1th term, now I'll have ar to the n minus 1. And at the nth term, I'll have plus ar to the n. Now what I see is multiplying this by r, all of those middle terms are actually the same. So if I subtract these two things, I'll be able to eliminate all of those middle terms. So in other words, I'm going to do s sub n minus r s sub n. So a plus ar squared plus ar cubed. I forgot my ar, oops, plus ar squared plus ar cubed plus dot 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 plus ar to the n minus 2 plus ar to the n minus 1 minus, now what I'm subtracting away, actually I'm going to move my minus sign down to the bottom, minus ar plus ar squared plus ar cubed plus ar to the fourth plus dot 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 plus ar to the n minus 1 plus ar to the n. Okay, so what I see here is that all of those middle terms, like we said, they're the same. So they're actually going to all cancel out. That ar, look, I'm subtracting ar squared, I'm subtracting ar squared, ar cubed, I'm subtracting ar cubed. Well, there's going to be an ar to the fourth next, so that ar to the fourth is also going to get canceled out. The ar to the n minus 2 will get canceled out with something that's right there as well. And then these ar to the n minus 1s will also get canceled out. So I see that what I have left, s sub n minus r s sub n, is equal to the only thing left in the beginning was a, and the only thing left in the end was a r to the power of n. Now, remember my ultimate goal is to find that general term. I want to find S sub n. So now I'm going to isolate S sub n. So first I'll factor out S sub n over on the left side. 1 minus r is left over. At the same time, I'm also going to factor out that a on the right side because we're trying to show that it is that form up there. The a is factored out. So a, 1 minus r to the n. And then all we have to do here is divide by that 1 minus r, which will then tell me what's left over on the left is S sub n. On the right, we have a times 1 minus r to the power of n over 1 minus r. So note that this clearly does not work in the case where r equals 1, but that's okay because we know that the geometric series diverges then anyway, because that would be like doing 1 plus 1 plus 1 plus 1 plus 1 plus 1 over and over again an infinite number of times. So clearly that gives me infinity. So this S sub n does not work. For r equals to 1, but again, like we said, not a big deal. Anyway, hopefully this is helpful in understanding where that general term came from. That's all. Bye, guys.